Welcome all to our channel. In session 16, we are going to have a look on designation of limits, fits and tolerances. How to find whole and shaft designation. If you are looking for the answers, please watch the video till end. If you are new to this channel is completely about engineering. If you are interested, please subscribe and select bell icon for latest videos. List of points from session 16 we are going to see are about ISO limits and fits, types of fundamental deviation, fundamental deviations for whole designations, fundamental deviations for shaft designations, formula for fundamental deviations of shaft and hole, formula for standard tolerance grades. About ISO limits and fits. Fits have been standardized and can be taken directly from standard chart ISO 286. Standard chart refers to tolerance symbols made up with a letter followed by a number. Selection of pair of these tolerances will give you the fit. ISO standard chart offers a range of fits suitable for most engineering applications. Capital letters always refers to holes and lowercase always refers to shafts. Types of fundamental deviations. Fundamental deviations for hole designations, fundamental deviations for shaft designations. There are 25 types of fundamental deviations. These are indicated by capital letters for hole. There are 25 types of fundamental deviations. These are indicated by small letters for shaft. Fundamental deviations for holes. Upper letters from capital A to capital H will be used for clearance fit. Letters capital J, JS, K, capital M will be used for transition fit. Letters capital N, P, R, S, T, U, V, X, Y, Z, ZA, ZB, ZC will be used for interference fit. Letters capital I, L, O, Q, W will be excluded. Fundamental deviations for shafts. Small letters from A to H will be used for clearance fit. Letters small j, js, k, m will be used for transition fit. Letters small n, p, r, s, t, u, v, x, y, z, za, zb, zc will be used for interference fit. Letters small I, L, O, Q, W will be excluded. Letters small v, X, Y, Z are not recommended for use due to very large interference fits. Formula for fundamental deviations of shaft and hole. We have to understand that all the charts are given in IS 919 or ISO 286 standard. Now we can directly find out the fundamental deviations using those charts. Before going to calculation part, without looking at the chart, how we calculate fundamental deviation values using formulas. This is the first chart we are going to refer. In this chart, we have 25 fundamental deviations which are given for holes from A to ZC, capital letters, and for shafts from small a to small zc, we have a basic ranges given. Small d and capital D equals 16 d to the power of 0.44. Small e and capital E equals 11 d to the power of 0.41. Small f and capital F equals 5.5 d to the power of 0.41. Small g and capital G equals 2.5 d to the power of 0.34, where small h and capital H, small k and capital K fundamental deviation will be 0. Small m and capital M equals 0.024 d plus 12.6. Small n and capital N equals 0.04 d plus 21. Small p and capital P equals 0.072 d plus 37.8. Small s and capital S equals IT7 plus 0.4 d. Small t and capital T equals IT7 plus 0.63 d. Small u and capital U equals IT7 plus d. Now how this formula is used, what is this d is all about, we see it later. Formula for standard tolerance grades. All the standard charts are given in IS 919 or ISO 286. We can directly find out the tolerances now using those charts. Before going to calculation part, without looking at the chart, how we calculate tolerance values using formula. This is the second chart we are going to refer. In this chart we have 18 IT grades which are given IT1 to IT18. If the basic size ranges up to 500, then we are going to use the standard tolerance factor small I. Formula is I equals 0.453 root d plus 0.001 d. If the basic size is more than 500 to 3150, then we have to use capital I. Formula is I equals 0.004 d plus 2.1. Similarly, we can see here there are multiplication factor. Once you calculate the I, we have to multiply it in order to get the tolerance for particular dimension. Now, how this formula is used, what is this d is all about, we see it in upcoming videos. Thanks for watching. If you like the video, share your comments, subscribe our channel. It will boost me to post subject related technical videos which are relevant to the industry and upcoming technologies outlook.